The riverbanks not only form part of our landscape, they also fulfill many functions. In natural systems, they allow for the development of appropriate vegetation, the so-called riparian forest, that forms a valuable interface between the river and the surrounding land. However, when the banks are degraded by infrastructures or weakened by erosion, they can no longer fulfill their protective role. Although erosion is a natural process that contributes to the proper functioning of the waterway, it becomes necessary to protect the banks when it threatens infrastructures, such as a road or a building. In order to meet these constraints while restoring biodiversity and the various ecological functions of riverbanks, technical restoration techniques based on the use of living plants exist, which are known as nature-based solutions. Soil-water bioengineering techniques are being increasingly used in the context of riverbank restoration and offer different types of structures depending on the constraints faced. Among them, fascine techniques are the most frequent in France. They are most often used at the foot of the bank and consist of placing bundles of living willows attached to piles. Using naturally occurring woody plants on the surrounding banks makes it suitable for many situations and forms the first natural fortification for the bank. Once placed, the roots envelop the gravel and rocks in the soil to reinforce its cohesion. The whole will create a durable anchorage for the bank, which will become stronger over time. Fascines must be placed at the right altitude. Too low and they will be submerged, too high and they will dry out, and in both cases, they will die. They should generally be placed level with the water, at the average level of the lowest willows naturally present on the nearby bank. But although this relatively simple design offers many advantages in terms of protection, implementing it in the field requires some expertise. From the selection of the branches that will form the bundles to their installation in the river, there are some major principles and constraints to consider in order to guarantee the success and durability. On projects using plant techniques, willow is the most popular woody species, since it guarantees a good resprouting rate and strong regrowth. Willow species mostly like wet soils, which is why riverbanks are ideal for their use as construction material. Choosing local species ensures that they are adapted to the site conditions. The different willow species are difficult to recognize during the dormant season since they have no leaves. However, choosing the right species is of the utmost importance. To avoid errors, willows are identified and marked on site as early as possible in the season. In most cases, the work is carried out in autumn, the period when the plants are dormant. On collection sites, whole stems are cut up and then transported directly to a nearby site to sort and make the necessary cuts. Stakes, cuttings, and branches are selected and cut according to well-defined calibers and according to the needs of the sites. For instance, for fascines at the foot of the bank, bundles of branches with an average length of 2 meters and a diameter of 2 to 5 centimeters are assembled. After collection, storage and transport must be reduced as much as possible to avoid any deterioration of the cuttings. They are quickly transported to the construction sites, as living material must be used quickly after cutting. If immediate intervention is not possible, then it is advisable to put the willows in water, or ideally in a cold room. Preparation and progress of the construction site must be coordinated with the arrival of the cuttings. Thus, the shape of the bottom of the bank is carried out ahead of time. Fascines at the foot of the bank are usually accompanied by other techniques above, namely geotextile, cuttings, brush mattress, brush layers, etc. In order to prepare for the installation of the fascine, 2 rows of dead or live stakes are placed at the foot of the bank, at least 50 centimeters deep. Some adaptations are made depending on the context. 60 centimeters to 1 meter separates them. The width of the row should match the size of the willow bundles to be placed there. At the foot of the row, the sole of the fascine must be stabilized. A major cause of failure is scouring under the fascine. Using anti-scouring twigs can reduce this risk. Thus, to improve the resistance of the structure, these twigs can be placed in a perpendicular direction to the current under the fascine in order to trap the sediments and limit erosion intensity related to the flow while the roots are growing. After this step, the willow bundles that will form the body of the fascine are placed. The feet of the stems must come into contact with the soil. For a better recovery, soil or gravel or earth materials are placed in the fascine. Sometimes, a geotextile anchored in the foot of the bank and enveloping the bundles can be used to improve the strength of the whole. The bundles are then placed successively in the row of stakes overlapping each other, the foot of the bundles being systematically placed upstream of the river. Once the fascine is fully filled, and if there is a geotextile, this is folded down to form a wattle, and the package is held tightly to the stakes and bank with wire and staples. The stakes can be driven another time once the fascine is in place, before being recut. Once the fascine has been laid, the height of the stake tops is adjusted so that they stick out only a few centimeters above the bundles. After completion of the project, the strength and resistance of the structure depends on the design methods, but also on the weather conditions in the first year, knowing that major floods at the beginning of the growing season and droughts are the main factors that limit the proper start of the project, and sometimes even result in its failure. Once the work is completed, the dormant plants will awaken in the spring to start growing and settle on the bank. The structure then becomes alive and integrates more and more with the surrounding environment, thus giving back all its protective functions to the bank.